Hello and welcome back to Physics Safari. My name is Abhishek and today we shall discuss on slope and the differentiations. All good? So far we have discussed on the sort of binomial expansion and the trigonometrical identities and the functions. All good? Now before I get into the slope and the differentiations and stuff like that, or the rate of change, whatever you say, let me just ask you one thing. What is the meaning of coordinates? What is coordinate? Well, the coordinate in a very simple language is defined as address of a point, whether it is a 2D or a 3D. All good? Now, let's say for example, probably if I have this x-axis and the y-axis. I'm just talking about the two dimension. I have a point P over here with, let's say, some coordinates of x1 and y1. Now let me tell you what is the meaning of x1 and y1. So for example, here is the point. Then x1 represents the distance of this point from the y-axis, and this y1 represents the distance of the point from the x-axis. Now x and y-axis are the referral quantities. For the reference we need something. For example, if you give the address of a house, you might be using a landmark like probably the close to CCD or maybe close to any such things which is probably known, well known more than your house. So here we have this y1 is going to be the distance from the x-axis. So this point, this length is as it is x1, so this point should be written as x1 comma 0. So from here I got an idea that the first part represents the distance along the x-axis and the second part represents your distance along the y-axis. So this length is going to be y1 and this length is going to be x1. And these two are the coordinates of the point P. Let's say I have moved from point P to, let's say, point Q. And this point has coordinates, probably I can say x2 and y2. All good? So when you see that when you move from x1 to x2, your x coordinate have changed and the y coordinate also have changed. That clearly means that you have moved along the x-axis as well as along the y-axis. Both the movement has been taken care. Both the movement took place. So my dear guys, my dear students, if I just, let me just increase it. If I drop down a perpendicular from here and let's say I want to know the coordinates of this point, I believe you guys know it, right? So it should be how much? x2 comma 0. Okay, let me also drop a parallel line to the x-axis which meets at, say, let's say point R over here. This is your point R. Okay, now write on the coordinates over here of the point R. Now that should be how much? x2, because when you move vertically, your x does not change, right? And when you move horizontally, your height does not change. And we had discussed that height will be taken care by the y coordinates and the horizontal movement will be taken care by the x coordinates. So this y coordinate would remain same, that is of point P. So you can see that while reaching from point 2P to Q, I had made some vertical displacement or vertical movement, you can say. I would represent that with delta y, that is change in the y. Well, that should be easily written as how much? y2 minus y1. Likewise, the horizontal change delta x could be written as x2 minus x1. All good? Now, I have reached from point P to point Q along this path which I have used the red color to represent. I could have also moved with along a different path which would have had a different sort of inclination, right? So there must be some mathematical tool which can control the steepness of a line segment or a line, right? And that is called as slope. So slope in very simple language can be defined as all about steepness of a line. And how would we measure the steepness? Of course, if it is less slant, the change in the y would be less. For example, let's suppose this is another way of reaching some point Q over here. So this would be less compared to what we had in this point Q. So this is less inclined, less slant. It means it will have a smaller slope. So in terms of maths, slope is all about the steepness, which tells the direction and the steepness of a line. It tells you the direction as well. I'm going to discuss about that, how the direction could be decided. Okay, in the layman's language, the slope could be defined as rise over the run. Run along means x-axis, rise means y-axis. We represent the slope with small m, and rise how much? dy, delta y is the rise. So we have delta y upon delta x is the run. Okay. So here we have the slope m equals delta y upon delta x. If I want to put it across in terms of the coordinates of the point, then my dear guys, slope would be written as delta y is how much? y2 minus y1 and upon x2 minus x1. So this is one way we have to find the slope. But that's not the only way in which we can find a slope. We also can find a slope if the angle that this line is making with the x-axis is known to you. What I'm going to do is, let me just reduce it backward, this red line, I'm going to use this blue color, which probably could be visible. It is making some small angle, let's suppose, or maybe whatever angle, not necessary it has to be small, just theta over there. Now, which angle should I report? That should be taken in the anti-clockwise direction from a point on the right hand side of the point of contact with the x-axis, taken in the anti-clockwise direction. If this angle is known to me, then the slope could also be written as tan of theta. Now, how we know if it is tan theta? Very simple. If I look into a triangle, a right angle triangle, and if it is theta, as we can say this triangle PQR. If it is theta, of course, this is also going to be theta. Reason being, this line is parallel to x-axis. So if it is theta, okay, then tan, okay, let's suppose this is right angle. Let's suppose this is A, B, and C, right? Or maybe we can just write, let's say P as what I've used over there, Q, and let's say this point is R. Then tan theta, my dear, is going to be given as what? QR upon PR. Same as delta y upon delta x. So the second way of finding the slope is when we know the angle of inclination of the line with your x-axis. All good? Now going further. Since I know PQ could be taken as a line, it could be taken as a line, so there must be some other ways in which we can find a slope. These are not the only two ways in which we can find a slope. But to know that, let me first define you the line. Okay, so probably I'm gonna erase this part. I'm sure you guys must have noted down these two stuff, how to find a slope. So two ways already we have known to find a slope. One, when the coordinates of 2 points is known to you on that line of which we have to find a slope. And the second way is which when we have the angle of inclination. If that is known to you, you can also find the slope. As simple as that. Now let us talk something about the line. Now, how do you define line? So in very simple language, line is the locus of points moving in straight path. Do not say collinear points, because the collinearity came only after the line was defined. So the points falling on the line are called the collinear points. So what I'm going to say, line is locus of point moving in straight path. You may note down locus of points moving in straight path. That's called the line. Now, the general equation of line that we have, the first general equation of line. So, every first degree equation represents the straight line. So, when we have ax plus by plus c equals to 0, well, that would represent a straight line. So, all first degree equation represents the straight line. Now, the second and the very important format of line that I want you guys, all of you to know, is called the slope-intercept form. Now, this is very important. The reason being, it would help you in various ways to find the slope and to find the intercepts on the y-axis. It's actually a crucial one, okay? So let's just first write it down. That is given as y equals mx plus c. Now, let me help you to understand what does this M and C stands over here. M already we have seen, this would be the slope of the line. This would represent the slope, and this new term y is all about your y-intercept. Now you might be wondering, what is y-intercept and what is the meaning of intercept? Of course, this is called intersection. If something is intersecting, that's called intersection, and the point where it intersects is called the point of intersection, or intercept in simple language. So let me just have your y-axis and your x-axis. If I draw a line like this, well, this is a point where this line is intersecting the y-axis. Let's say this is a y-axis. So this is called your y-intercept, and this length is your C. That's what C is over here. One more thing I would like to add over here, if I have the equation of line, let's suppose it is given as ax plus by plus c equals to 0. And someone asked me to find the y-intercept, and this is your x-intercept. This is your x-intercept, because that is the point where the line is intersecting with the x-axis. So if I want to find the x-intercept and the y-intercept, what I can do is, let's see, to find x-intercept, what I'm going to do, and to find y-intercept, let's see what we need to do. If I look at this x-axis, I'm sure you guys must agree with me that the value of y on this x-axis should be 0, because y-axis, this is the origin 0, 0, and this on this x-axis, the y coordinate would be 0. So its another name is also given as y equals to 0, and likewise the name of this also is given as x equals to 0. All good? So x equals to 0 is the name of the y-axis, and x-axis is called as y equals to 0. So if I want to find the x-intercept, it means at this point, I'm sure you would agree that the value of y is going to be 0. So if I replace the value of y as 0 in this equation, I would be getting the value of the y-intercept, isn't it? Well, so replace, to find the x-intercept, replace y is equals to 0 in the equation. Which equation? Equation of this line. Now please don't make this C and this C equal. Just to avoid confusion, let's say this is C1. All good? And to find the y-intercept, at this point, the x has to be 0. So to find the y-intercept, you just need to replace x equals to 0 in your equation, and you will be getting it. As simple as that. Let us see how. I'm going to give you a general example. Let's say I have an example of line, probably 2x plus 3y plus 6 equals to 0. Let's suppose there is a line. I want to find the x-intercept and the y-intercept on this line, which it is making on the x and y axis respectively. Okay. So let's say to find the x-intercept, as we know, we have to replace y equals to 0. Now let me just write y equals to 0 over here. That means 2x plus 3 times of 0 is 0 plus 6 equals to 0. That means 2x is going to be equals to negative 6 and x has to be negative 3. So this is going to be your x-intercept. Likewise, if I want to find my y-intercept, what I'm going to do, I'm going to write x equals to 0 in this given equation. That would give you just 3y equals to negative 6. That means y equals to negative 2. That is your y-intercept. So if I want to draw the line, of course we can do that. So let's suppose here we have the line, and it is making some negative intercepts on the x and y axis. So let me just try and put it here. Okay. X-intercept is negative 3. Means let's say somewhere here. This is your negative 3. Y-intercept is negative 2. Maybe somewhat here. Then the line, this is your negative 2. Then the line has to be like this. Just assume it's passing through this point. Okay. So this is the line. This is how we can draw the line. Now, so there's a difference in these two lines, right? So this is making the positive intercept. This is positive and this is also positive. And here, this is making the negative x and negative y intercept. All good? So this helps me to find the x intercepts and the y intercept. Now, where this will be required in physics? In various cases, when the linear motion, when we are dealing with the linear motion, you will have to deal with the graphs, especially the lines. This wire has tackled. Okay, anyways, all good? Now, let me take you to the third format of the line. So we have seen the general equation, the slope intercept form, and now, since I have learned how to find the intercepts using the replacement method, where we have to replace x equals to 0 and y equals to 0 respectively to find the y and x intercepts. Now, I'm going to discuss with you the intercept form of the line. And with that form, you can actually get the x-intercepts and y-intercept in a single take. All good? So yes, I'm sure you must have noted it down. If not, pause the video and first note everything down. Now, the next that I want to discuss is the point number 3, type 3 of the line. That is called the intercept form of the line. Intercept form of the line. So, as the name suggests, this will intend to talk about the intercepts made on the x and y axis. Its general equation is given as x upon a plus y upon b equals 1. What is a and b? Well, that's a thing that we need to know. This represents your x-intercept and this represents your y-intercept. Okay, fair enough. Then how the line is going to look like? Well, the line should be like this. Here we have the x and y axis, let's say x and y axis. It could be anything. Let me just have a general line, maybe like this. So this length, my dear, is going to be your a, that is your x-intercept, and this is going to be your b, that is your y-intercept. Now, how can I make use of this equation? Why, we just have seen how to find x-intercept and the y-intercept. I mean, like, then why do we need this? Because this can help you to get the intercept in just one form, one way. How? Let me just give you an example. So, let's say probably in the same example, we have 2x plus 3y equals to 6. Now, one thing you must make sure that 1 should be there on the right hand side of the equation. And everything as a coefficient of x and y should be in denominator. There's nothing that should remain as a multiplications with x and y. Everything should be in the denominator with 1 being on the right hand side. If I look at this one, I believe I must divide by 6 to get it 1 towards the right hand side. Okay, so let me just divide everything by 6. So that would just give me how much? X upon 3 plus y upon 2 equals 1. I have my x and y intercept. That's all. So the moment you have this, you can just draw your line with x-intercept being 3, the y-intercept being 2, and the line would be like this. All good? Right? Now, let us see the third is done. Let's see the fourth form of the line. Well, I call this as a 2 points form. 2 points form of the line. Form of line. That means if I know the 2 points, I can easily find the equation of line. The reason being, I know that with the 2 points given, we can just have one line. So from 2 points, we can just draw the one line. So let's suppose this point P with the coordinates x1 and y1. This point is Q with the coordinates of, let's say, x2 and y2. If I want to find the equation of line, we can easily do it with the format y minus y1 upon x minus x1 equals y2 minus y1 upon x2 minus x1. Lot many times, many students have asked me, sir, what is this x and y? Well, these two are the representative of your x and y axes. Because if you move from here to here, let's suppose here to here, of course your x and y both are changing. So there must be some parameters which can help you to understand that what is changing. So these x and y are the representation of the x and y axes. Now let me just give you an example where I can just show you how to use this. So let's suppose this point probably, let's say 2, 1, and this point I choose 3, let's say 4 or something like that. Okay. Now I want to find the equation of line which is passing through these 2 points. Not a big deal. I'm going to choose. Okay. Now one more thing I want to add. You can choose this as x1, y1, or you can also choose this as x1, y1. But if you're choosing this as x1 and y1, this must be x2 and y2. That has to be ensured. वो उल्टा नहीं करना अपन को, है ना? So y minus y1. So let's suppose that is going to be 1, and we have, let's say, x minus x1, which is 2 over here. Likewise, y2 is how much? 4. So it's going to be 4. Y1 is how much? 1. And x2, which is 3 minus 2. Okay, that's going to be how much? 3 upon sort of 1. Okay, we got the solution. We got the equation. Just a cross multiplication is required. So y minus 1 equals 3 times of x minus 2. So y should be equals to how much? If I write 3x and negative 6 plus 1, negative 5, right? So this is your equation of line. If I want to draw it, I can easily understand that the slope is a positive value 3. It's a positive slope. Okay, let me just add one more thing, my dear, to how to understand whether the slope is positive and when we can say the slope is negative. Okay, I'm going to take the help of these two diagrams. If I look at this angle, theta, I'm sure theta is going to be an acute angle. It should be less than 90 degree and should be more than 0 degree. This is an acute angle. This is an acute angle. And if I look at this one, see this one. This theta is going to be more than 90 and of course less than 180 degree. So here the theta is an obtuse angle. It's more than 90, less than 180 degrees. In the trigonometrical part, I've told you that tan is positive in the first quadrant and in the third quadrant. In the second quadrant, tan is negative. So if you look for this angle of tan for this angle, that is going to be positive. If you look for this angle, tan of this angle, that is going to be negative. So one rule you can understand, if theta is acute, the slope is going to be positive value. So here the slope is going to be a positive value. And if theta is an obtuse angle, the slope is going to be negative value. That's an easy way to understand whether the slope is positive or negative. That's how we can understand the slope being positive or negative. If I look at this one, the slope is 3, which is positive, with a y-intercept of minus 5. C is minus 5 and slope being 3. So, okay. Now, I know one thing. The y-intercept is minus 5. So, somewhere here, let's suppose. Slope is positive 3. Okay, this could be like this. Okay, this line is definitely not passing through this. So, yes. Right? Now, I did not bother to find the x-intercept because I just drew the rough diagram. If you want to find the x-intercept, of course, you can put y equals to 0 in this line. You can get the x-intercept. So, to put y equals to 0, if you put y is equals to 0 over here, let's say put y equals to 0, that implies 3x should be equals to 5 and x is going to be 5 upon 3. So, yes, this point you can write as 5 upon 3. So, that is your x-intercept and you know the slope. Okay, this mic is sort of falling down. Anyways, so that we have discussed the 4 formats of the line. The first one, the general equation. Second was the slope-intercept form. Third, we have spoken about the intercept form. And the fourth one is the 2-point form. Now we are going to discuss about the 1 point and the slope form. That means if 1 point is given and the slope is given, we can find the equation of line. So that is the fifth and the last format which I would like to discuss with you. Okay, let me just erase this one. And I'm sure you guys must have noted it down. All right then. Okay, and meanwhile, I would just like to tell you, if you get some doubts or you want to discuss something with me or you want to ask me something, of course, the comment box is open for you. Don't hesitate in asking stuff there. Okay, now the fifth format is 1 point slope form. 1 point slope form. If I have this 1 point and slope, I can easily find the equation of line. Well, this is nothing but the extension of the 2-point form, I would say. So this is given as y minus y1 upon x minus x1 equals m. Now, what is x1 and y1, my dear? So let's say I have a line passing through the point having coordinates x1, y1, and this line has a slope, let's suppose m. Then I can find it. All right. Okay, so let us have an example. Let's say I want to find a line passing through point 2, 3 and having slope, let's suppose 1 upon 2. Not a problem. If you have these kind of situations, you can just write y negative 3 upon x minus 2 equals slope, which is 1 upon 2. Rest is just a cross multiplication. So y equals to, probably I can just write how much? 1 upon 2 times of x, and negative 1 plus 3, that's going to be 2. So y equals 1 by 2 times of x plus 2 is going to be the line over here. Also, I want to add one more thing, that is called the distance formula. That is called the distance formula. If I have 2 points, distance formula. If I have the 2 points and I want to find the distance between them, for example, I have the point A with the coordinates x1, y1, and I have the point B with the coordinates of x2, y2. If I have these 2 points and I want to find the distance of AB, length of AB, this is AB. So the AB should be easily given as x1 minus x2 whole square plus y1 minus y2 whole square. That's how you can find the distance of the points, probably line segment. Also, if I want to find the midpoint of AB, if I want to find the midpoint, coordinates of the midpoint, let's suppose this is probably alpha with some coordinates h comma k. Then the value of h, easily we can say x1 plus x2 upon 2, and the value of k, that's going to be y1 plus y2 upon 2. So that way we can easily find out the midpoints. All good? Now, having done with the slope, now since we're talking about the 2 points that were kind of far apart, so this is going to give you the change in y with respect to change in x. Now that y axis and x axis could be completely based on your convenience. If you want to check the y axis as a distance or the displacement and the x axis a time axis, that would give you the change in the distance or displacement upon time, and that is what going to give you the velocity or the speed. So understanding the graph makes your life simple, and there are going to be a lot of things that we're going to deal in the kinematics topic where we need the graphs concept. One more graph that we need to understand before I jump into the derivatives and stuff like that is the graph of the quadratic function, which is a parabola. So let me quickly help you to understand the graph of a quadratic function. Okay. Now, if I just say what is quadratic function, a little bit about the quadratic, I would like to help you. Quadratic function. So the standard format is ax square plus bx plus c equals to 0 is the quadratic equation provided a is not equals to 0. Because the moment a becomes equals to 0, this is going to be a linear equation. So a should not be equals to 0. Now, having seen this, as the power of x is 2, I must be having 2 points where the value of this polynomial becomes 0. Okay, so if I just have this, what do we call it? It's a quadratic polynomial, right? It's just an algebraic expression which have variables, constant, plus or minus or multiplication. But the moment I equate this with 0, this becomes quadratic equation. All clear? So now since we have the 2 values of x, so normally we call them as roots, or we also call them as zeros, or the solution of the quadratic equation, quadratic function. So generally we have been following this trend of representing them with alpha and beta, and this could be given as what? Minus b plus or minus of b square minus 4ac upon 2 times of a. Now while I'm going to teach, especially the vertical motion, I'm going to use this. And don't say at that time that you have no idea about this stuff, okay? So alpha and beta would be given as minus b plus minus of b square minus 4ac. Okay, one more thing I would just like to, where I want to have your attention. Let's suppose if this part was 0. If this part was 0, then alpha and beta both would have been equals to how much? Negative b upon 2a, because this part wasn't there. So the whole reason why we have 2 values of alpha and beta, different values of alpha and beta, is the existence of this parameter. And that's the reason why we call this as discriminant, because it is creating the differences between the roots. So this is called discriminant, and this is given as b square minus 4ac. It has its own significance, guys, it has its own importance. You will get to know about it. So finally what I can say, this alpha and beta could be written in the reduced form as minus b plus or minus of root of d upon 2 times of a. All good? This could be written as alpha beta. Okay, now there are going to be situations that could be sort of decided by the value of d, and those situations could be for the values of alpha and beta. But before I jump to that part, let me just tell you, if I have the two values, what we can do? We can add them, we can subtract them, we can multiply them, probably we can divide them also. So first of all, let us understand what if I add them. So that is called sum of the roots. Sum of the roots. That is alpha plus beta, and referring to this equation, alpha plus beta would be given as minus b upon a, and alpha into beta is given as c upon a. So this is a very handy tool. What is alpha into beta? This is the product of the root. Product of roots. That's a product of the roots. Alpha into beta is the product of the roots. Okay, now one more thing. I'm sure you are aware of how to split the middle term. If not, let me just help you with one example for that also. Let's say, example, if I have x square, probably x square minus, maybe I can say 8x, and I might write negative 20. I want to split the middle term. What exactly we do? We take the factors of this number 20. So they're going to be 2, 10, 2, 5, and 5 and 1. Okay, so this is not going to work out, right? Why not? If it is negative, and if it is negative, both are negative. We have to split this, not just for the negatives, we have to split this in two parts such that when we add those two parts, I should be getting this middle term along with the sign. And when I multiply those two parts, I should be getting the constant, and because here the coefficient of x square is 1, so multiple of minus 20 and 1 is minus 20 itself. So when I multiply those two parts, I must be getting this part along with the sign. So here we have negative, and also here we have negative. So multiple of two term is giving you negative, means one among them has to be positive and the another has to be negative. The center term is negative, it means the greater among those two terms has to be the negative. I believe 10 and 2 would serve the purpose. So here we have x square minus 10x plus 2x minus 20, isn't it, my dear? See, when I'm adding these two, I'm going to get this. When I'm multiplying these two, I'm going to get the minus 20. Of course, x square over here. So now among these two, take the x common. You will be having x minus 10, and take the 2 common from here, you will be having x minus 10 again. Now from this term and this term, take x minus 10 common, and that would give you x plus 2 over here. If I equate this with 0, and I just want to find the value of the x for which this polynomial becomes 0, then I should be getting how much? X equals to 10 and x equals to minus 2. Oh ho ho! What are these two values representing over here? They are nothing but your alpha and beta, you can assume. You can take otherwise also, beta and alpha, but just I'm taking for random reason. So alpha and beta. Okay, and these are the roots of this particular equation. Now I'm going to go vice versa. I'm going to go in the opposite direction. Let's say I have been given these two roots, and I was asked to find this equation. Now for that we have a special format that says the required equation could be written as x square minus sum of the roots times of x plus the product of the root. That is 0. Over here, if I add these two, how much I'm going to get? A positive sort of 8. So we have x square minus positive 8 times x, and the product 10 times minus 2 is negative 20. That's 0. See, isn't this equal to that? So this is the standard way of reciprocating the equation of which the roots are given to you. Now, if I go into the graphic, I'm sure so far all good, everything is clear how to find the sort of values for the roots, how to sort of split the middle term and stuff like that, you have got to know. Now, what is the meaning of discriminant and how that is going to decide the nature of graph? That is what we are now going to discuss. Well, the quadratic equation, when I want to sort of put in terms of graph, that would be a parabola. So the next thing that you need to know, that you must understand, because that we're going to discuss more in detail when we talk about the acceleration and the deceleration. There we're going to discuss more about that. So the next thing that I'm going to talk about is the parabola, and I'm going to sort of relate the parabola and the quadratic equation. So it's just a quick thing. In maths, you will study more in the conic section. So basically, we have two standard forms of the parabola. One that is y square is equals to plus or minus of 4ax, and the another one is x square is equals to plus or minus of 4ay. Generally, I'm not saying that it has to be. Generally, we deal with the quadratic in x, rather dealing with the quadratic in y. This is more oftenly seen. So we're going to focus more on this, of course, but I'm going to see everything. So let me first look at this one. The positive part, y square is equals to 4ax. This a is called the focal length, and the length, as you all know, can never be negative. Length has to be a positive value. Now what really I want to convey from here? I want to say that this y square, being a square term, it will be a positive value without any doubt, right? 4a together is going to be a positive value, no doubt about that. This is positive, this is positive. This poor fellow x has no choice but to be positive. X will be positive, right? It means even if I choose a negative or a positive y, the x is going to be a positive value. So if I want to put it up across in terms of graph, see this out. Whether y is negative or positive, the x being positive, I know that x will be positive over here, either in the first quadrant or in the fourth quadrant. Y could be positive here and negative over here. So as from this, even if it is a positive y, I'm going to have positive x. Even if for the negative y, I'm going to have positive x. The graph would look like this. This is going to be the standard graph of y square is equals to 4ay. And if I just have, let's say y square is equals to minus 4a sort of x, in that case, I'm going to get the mirror image of this graph as y-axis acting as a mirror. So here we have. This is a graph for this equation. As simple as that. Now, let me talk about the second thing, which is your x square is equals to plus 4ay. The same rule would be, applicable over here. X square being positive, no matter if x is positive or negative, x square as a whole will be a positive quantity. So this x square is going to be a positive quantity. 4a being a positive quantity, reason being the same. So this fellow y has to be positive, no choice for him. And y is positive either in the first quadrant or in the second quadrant. So let's say this is y-axis and this is your x-axis. Then the graph is going to be like this. And if I look for the x square equals to minus 4ay, then the graph is going to be the mirror image. Or you can say the image acting x as a mirror. So here we have the graph. All good? So this is a bit of understanding of the parabola for you. And this point is called the vertex, where the parabola takes the turn, As of now, you can see the parabola was going towards the origin. From here, it's going away from the origin. So this is called the vertex. This point is called the vertex. Normally, we represent this with capital A. And in this one, this again is going to be the vertex. And in all the situations, all the cases, we have seen that the vertex is at the origin. Not necessarily it has to be at the origin, it could be anywhere. But those things you can discuss more in detail in maths. Now, what I wanted to tell you over here, how D is responsible for the nature of the roots and the curve. How is that going to dictate the, sort of the curve nature. Okay, so let's say, first thing I want to put it up across over here is, let's say I have probably a parabola and that is intersecting the x-axis at two distinct points. So this is your quadratic equation, of course, ax square plus bx plus c equals to 0, of course a not being 0. This is your function, so let's suppose your f of x is given as this, and of course that is y equals to f of x. The value function is 0 at these 2 points, as you can see here. At these 2 points it is intersecting with the x-axis, so the y is going to be 0 at these 2 points. That means those values of x for which these 2 points the value of function becomes 0, and we have seen that is called as what? Roots, equations, or solution. So can I say this is my alpha and this is my beta? So basically we are having what? Real and distinct root. Real and distinct roots. And it is possible when d is more than 0. And what was d? D was b square minus 4ac. Now it's coming quite handy. With the value of d itself, you will be able to understand whether the roots are real and distinct, or do we have something else. So let us see the possibilities. There could be cases when the graph would come like this, would just touch it and go back at a single point. So alpha and beta are both here only. So that is alpha will be equals to beta. So that is the case number 2 when we have real and equal roots. Real and equal roots. Both the roots are real and equal, and that is possible when d is equals to 0. Point number 2. Also, the third case that could prevail is, let's suppose there is a x and y axis and the graph is not even touching the x axis. It means there is no value of x for which the value of function is 0. Fx is not equals to 0 for any real value, of x, real value of x. And what it is? It is a case of imaginary roots, means there is no real roots existing. So case number 3 that we have is the imaginary roots. Imaginary roots. And that case d has to be less than 0. Why d has to be less than 0? If you remember, when the alpha and beta was given as what? Minus b plus or minus root of d upon 2 times of a. We know that inside a root, if the value is negative, that is the imaginary number. So if this becomes lesser than 0, then that is when it becomes imaginary. So that is the whole idea behind this. All good? Okay. Now, so I believe this video has been longer. So I'm going to discuss the derivatives, differentiations, and integrations, and of course the maxima and minima in the next video. So I believe whatever we have discussed today, which is line, the slope, the quadratic, the graphs and stuff like that, I'm sure you guys have learned that properly. But I would advise you, probably you just make the notes. I'm going to upload each and every video. I'm going to upload each and every topic over here. So you watch in the sequence and try to make your own notes, so that during revision that would come really, really handy. And of course, revise it after maybe 1 or 2 days, because revision would definitely incorporate that in your mind, or else you will tend to forget. That's a very common phenomenon. Anyways, so thanks for watching, guys. I'm going to see you very soon in the next video. Till then, keep learning and keep studying. I'll see you guys in the next video. Thank you. Take care. Bye-bye.